Hey fifth graders, it's Mrs. Tremblay. It's time for lesson 6 in your chapter 4 packet, or your unit 4 packet. So go ahead and get out your math unit 4 packet, open it up to lesson 6, the standard algorithm for multiplication. And today we're going to look at multi-digit multiplied by a single digit. And we're going to start off with a little bit of review using our area model. And then you'll see how the standard algorithm, that's just the traditional way of solving it, came about. So just a reminder, I do want you to write everything that I write. Your notes should match mine. If at any time you do want to try these on your own, yes, that would be great, but please make sure that you pause and then press play to check your work to make sure that it matches mine. The intent of these notes is not for you to learn how to do this all by yourself. It's for me to guide you. You'll have opportunity to practice today with the assignment that's in there. So to start off, I have 36 times 4. And I've been kind of having you set this up where we put the lower amount on the smaller side of the rectangle. So I'm going to put 4 here. And then remember, when we use our area model, we break apart our larger number by place value. So 36 means I have 30 plus 6. Remember, we break it up into ones and tens. So I'm going to go ahead and draw a line here. This means that this side would be 40, this is 30, this is 6. And to find the area of each piece, I would just multiply its length and width. So this is 4 by 30, so I would need to do 4 times 30. And remember, we can do 4 times 3, which is 12, and then multiply that by 10, which gives us the 120. And to find the area of this piece, I take this times this. Remember, this side 4 slides right over and matches that. So 4 times 6 would give you the area of this piece. 4 times 6 is 24. So to find the area of the whole thing, we can take 120 plus 24, and yes, we get 144. So the answer to this is 144. And we're going to solve all 4 of these using this model. That's actually what you have to do in your math packet for this week. I want you to be able to use the area model. That is a standard you have to know how to do. All right, so the next one, again, if you wanted to pause and try it on your own, you can. Otherwise, just complete it right along with me. That's fine too. I'm going to put the 7 on this side because it is shorter and 7 is a lower digit, lower number. And I'm going to break this up into tens and ones. So I have 80 plus I have the 3. So 83, 80 plus 3, breaking that up by place value. To find the area of this piece, I would do 7 times 80. And I know that 7 times 8 is 56. That means that 7 times 80 would be 560, 0, 0. The area of this piece would be 7 by 3, and 7 times 3 is 21. So in order to find the area of the whole thing, the answer to this multiplication problem, I would add the area of each piece together to get an answer of 581. So you should have 581 for that. All right, next one, 98 times 6. All right, I'm going to put 6 here. Across the top, I'm going to write 90 plus 8, breaking it up by the place value. And 6 times 90, well, I know that 6 times 9 is 54, and if we multiply that by 10, it would be 540. And to find the area of this piece, I would do 6 times 8, which is 48. To find the area of the whole thing, we just need to add 540 plus the 48, which gives us 588. 588. All right, last one using this model, 9 times 39. I'm going to write the 9 here. I'm going to break up 39 into my tens and my ones. So I'd have 30 and then 9. And to find the area of this piece, I would take 9 times 30. And 9 times 3 is 27, multiplied by another 10 is 270. And this piece would be 9 times 9, which is 81. And now we need to add 270 plus 81. When I put my ones together, there's ones. 7 plus 8 is 15, and 2 plus 1 is 3. So 351. Okay, so this is how you use the area model. And again, yes, I do want you to be able to solve that using the area model. A lot of times I feel like we do this in our head. If I was to multiply 9 by 39, I would take the 9 times the 30. Oh, that's 270. Oh, plus the 81. These would be great number talk problems that you could do in your head, but when you're doing it in your head, you're actually using this when you break those numbers up. Okay, so now I'd like to show you the standard algorithm that will get us to this same spot. And when you set it up using the standard algorithm, it's set up vertically. vertically, straight up and down instead of across like this. And when you set it up, you put the larger digit on the top, and we put our lower digit underneath, and you are lining up those place values. So this 4 should go underneath the 6 because that represents the ones place. Now, when you solve using the standard algorithm, it's kind of just like what we did here. We're looking at this as taking the 4 times the 6 and the 4 times the 3, but this 3 represents 30, right? So here's what we do. We multiply the 4 by the 6, right? And now 4 times 6 is 24. So just like when you add, you can only put one digit at a time. I'm going to put the 2 in my 24, and I'm going to put the 4 in my 24, and I'm going to carry my 2. And a lot of times the confusion happens with, what do I do with this 2 now? Because we're multiplying. Well, the first thing you would do is, now I want to take this 4 and multiply it by the 30, right? Well, but the 3 in this. So 4 times 3, that's 12, right? Now when you look at this problem here, see how you have your 12 and your 2 underneath it? What did you do with the 12 and the 2 to get 14? You had to add those together. That's what you do with the numbers that you carry over in the standard algorithm. We add them in. So we're going to do our multiplication of 4 times 3 to get our 12, but then we have to add that 2, and 12 plus 2 is 14. So then we can go straight to the 144. The reason this works, I said this is like taking 30 times 4 and 6 times 4, right? Well, 6 times 4 is 24, and 30 times 4, without even solving this traditional way, we know 4 times 3 is 12, and then I have that extra 0. And then we add those together to get our solution there, right? So the kind of quicker, traditional, standard way to do this is just to do the 4 and multiply it by the 6, and then take the 4 and multiply it by the 3. It's like kind of like using the distributive property. So we'd get our 144. So let's try it with this next one. The next one is 83 times 7. And I realize we already know the answer is 581, but we're going to use our standard algorithm to prove that. So which number should you write on the top? You should write the 83 on the top. The larger number of digits should go on the top, and that's 7. I'm going to put right underneath the 3 so the ones match. Okay, now for this, I'm going to go, starting with my ones, I'm going to multiply the 7 by the 3. That's what happened in this box, right? We know that 7 times 3 is 21. I can't write 21. Okay, so I'm going to put my 1 in the 21 and carry my 2, kind of like you would in addition. Now, I know that 7 times 8, so I just did 7 times 3. I know that 7 times 8 is 56, right? And then here, when you got that 56, what did you do with that 2? We added it. So 7 times 8 is 56, plus the 2 is 58, so we get our 581. Hopefully you are liking this method. All right, 98 times 6, I'm going to write the 98 in the top spot, and I'm going to put the 6 right underneath the 8. And again, I'm going to multiply the 6 by the 8 first. I'm going to start with my ones. So 6 times 8 is 48. I can't write 48. I can only write my 8 and carry my 4. So there's the 48. 54. What am I doing? Sorry, it is like 5 o'clock in the morning. All right, so 6 times 8 is 48. Oh, I did have that right. I'm not stopping this. I don't care. 9 times 6 is 54, right? And then 54 plus 4 gives us our 58. So even though it's sloppy, yes, we have 588, which matches that. Okay, last one like this, and then we'll do just some standard algorithm practice. I have 9 times 39. I'm going to put the 39 in the top spot because that's a larger number of digits and multiply it by 9. Okay, so starting here, I'm going to do my 9 times 9, which we already did right there, right? 9 times 9 is 81. So I'm going to write my 1, because I only have place to write 1 digit, and carry my 8. Okay, so 9 times 3 is 27. That's this 27 right here, right? And then what do we do with the 27 and the 8? We added it in. So you'd multiply the digits in the problem, and whatever you had to carry, you add that digit at the end because you're putting those two things together just like we did with our area model. That's why this works. So when you take your 27 plus 8, I would do 27 plus 10 is 37, and then count back 2, because 8 is 2 less. And 2 less than 37 would be 35. So we get 351. Okay, on the next page, all we're going to do is practice this. And I gave you some grid paper just because I know when you're first doing this, a lot of times it's easier to be able to separate these digits by place value into the squares. So for letter E, it says, solve each problem using the standard algorithm. So 56 times 9, I'm going to label letter E right here. And to do 56 times 9, I'm going to leave this top spot blank in case I have to carry anything over. And I'm going to use 1 box per square, so 56, 5, 6. And I'm going to multiply that by 9 times 9. I'm writing that 9 right underneath the 6. Okay. So again, remember, this is like taking the 50 times the 9 and the 6 times the 9. I'm going to start with 6 times 9. 6 times 9 is 54. So I write my 4 and carry the 5, just like I would in an addition problem. And remember to get the other digits here. I already did 9 times 6. Now I need to do the 9 times the 5, and 9 times 5 is 45, right? And then what do we do with this 5 we carried over? Well, this is like putting both of our areas together. We add that 5 in. So 9 times 5 is 45, and 45 plus 5 is 50. So you should have 504. All right, write letter F. And for letter F, I give you a 3-digit multiplied by 1 digit. You can do this. 325, I'm going to put that in the top spot, 1 digit per box, and I'm leaving this for numbers that I carry. And I want to multiply that by 7. Okay. I know there are 3 numbers, but with the standard algorithm, it doesn't matter if there are 10 numbers up here. We use the same exact form. We're going from the 1s to the 10s to the 100s in terms of the order. So I know that 7 times 5 is 35. I'm going to write my 5 and carry my 3. Now I'm going to take 7 times the 10s place. 7 times 2 is 14. And then I would add that 3. So 14 plus 3 is 17. In 17, I write my 7 because that's the number of 1s and carry that. So there's my 17. Now I'm going to take 7 and multiply by the hundreds place. 7 times 3 is 21, and I add that top to get 22. And now I can write both the numbers because there's nothing left. I'm going to put in my comma. We get 2,275. All right, we're on a roll. Write down G. And the problem for G says 4 times 805. I know that the order that we multiply numbers does not matter, but it makes it a lot easier to use the standard algorithm if you write the larger number of digits on the top. So instead of writing the 4 on the top, I'm going to write 805 on the top. And I'm going to write 4 underneath. Put the 4 right underneath the 5, so they're both in the 1s place. And now we can go ahead and multiply through. I'm going to start with the 1s. 5 times 4 is 20. So there's my 0, and I carry my 2. And don't get freaked out when you see the 0. What's 4 times 0? 4 times 0 is 0. And then we add that number that we carry, just like we would add those area boxes together. So 4 times 0 is 0, plus 2 is, it's just 2. I didn't have to carry anything over, right? It was just 2. So now all that's left, I already did the 4 times the 5. I did the 4 times the 0. Now I need to do the 4 times the 8. And 4 times 8 is 32. And since I don't have any other digits left, I can go ahead and write my 32 and put in your comma. So we get 3,220. All right, we're halfway there. Whoa! I know, everything's a song. So go ahead and write down a letter H. If you wanted to pause me at this point and try to do 87 times 8 on your own, you're more than welcome to. If you're not ready for that yet, fine. Solve it with me. I have 87 times 8. I'm going to do 7 times 8 first. So I multiply the 1s place. 8 times 7 is 56. So I'm going to write the 6 in the 56 and carry my 5 over. Then I need to do 8 times 8. And 8 times 8 is 64. Now I need to add that 5 to the 64, which gives me 69. So 87 times 8 is 696. All right, we're on letter I, and letter I is 68 times 7. So I'm going to go ahead and write 68 times 7. Okay, 8 times 7, again, is 56. I can't write 56 here because I still have another digit. So I'm going to write the 6 in the 56 and carry my 5. 7 times 6 is 42. and then I have to add that 5 in. 42 plus 5 would give me 47. So you should have 476. All right, now if you haven't tried pausing me yet, now would be a great time. Pause it. Try to do 91 times 6, on your own. 91 times 6, but then be sure to press play to make sure you're right. Okay, I'm going to start with my ones place. 6 times 1 is 6, and 6 times 9, I didn't have to carry anything, right? There's only a single digit in my answer, so I just write the single digit. 9 times 6 is 54. I can go ahead and write 54 because there aren't any more digits to multiply. So you should have 546 for your final answer. That's it. That's how you use the standard algorithm to multiply a multi-digit number by a single digit number. Thanks for watching.